So this is the Higher Tier Double Award 2022 exam. So the first question gives you a lot of information about the mass of beads and the water that they have absorbed, and it gives you this nice equation. Okay, so it says calculate the percentage increase in mass of the bead after 2 hours. So there's 2 hours. Be careful that they tell you the initial mass up here is this, and then they give you the mass of water absorbed by the bead. Okay, so you take them two numbers away. That's how I got that value there. Divide by the initial mass times by 100, and you get this really large percentage increase number. What property of polymer gels does the figure calculate in part? I demonstrate the ability to absorb water 100 times, 1,000 times its size. Two differences between the properties of the beads using water at 10 degrees and at 40 degrees. Beads absorb more water at 40 degrees more quickly. Beads stop absorbing water at 40 degrees after 10 hours. Kind of question that we have practiced loads. Okay, so substance A is by here. So hydrochloric acid plus something makes magnesium chloride. It's got to be magnesium. Substance B then by here. So that's carbonate. So it's got to be carbon dioxide. Be careful, it says names there and then it says formulas. So formula C, that's copper chloride, and then substance D would be water. Then it says write the formula of sodium carbonate. So all you have to do is find sodium, find carbonate, and then do the difference between them, and then 2 there because there's 2 chlorines there. Silver nitrate was added to hydrochloric acid, so that's chlorine, and that's going to give you a white precipitate. And then click which of these will be right, because it's silver's plus. You can get them from the table of ions, so that's a nice easy question. Name the type of bonding present, so that's ionic. When can it conduct electricity? When it's molten or dissolved. I realise that's when you get your 1 mark. The second mark is right, and ions free to move. I'll get you the second. Drawing the covalent bond, because they're both non-metals. Okay, both non-metals, so drawing the covalent bond. Explain why it has a low boiling point. Molecules not joined, weak force of attraction, little energy needed to break these bonds. Okay. Lots of stuff about like nanoparticles. This entire first 3 questions has been basically that. Give a reason why nanoscale titanium dioxide is effective in each of these uses. So absorbs UV rays, reflects UV rays, sun cream, self-cleaning windows, catalyzes the breakdown of dirt. Explain why iron is formed during the reaction. So aluminium is more reactive than iron, so we'll steal the oxide, displace the oxide. Nice equation for it, simple equation, using your table of ions again. Okay, a lot of marks are found from just using that table of ions and then doing top, swap, drop, swap them, and then drop them. Okay, a lot of marks come from just doing that. Calculate percentage by mass of iron in iron oxide. So the first thing you need to do is work out the MR, okay, the total MR of iron oxide, and then divide it by the total of iron. Okay, so that's the total iron over the total MR. Place a cross on the diagram to show which tests are not carried out. So copper with copper, tin with tin. Okay, again an easy mark. Metals do not displace themselves. Okay, so there's 2 easy marks there. Then this is quite a complicated question. This is from year 10. Okay, this is year 10 work. It's reacting masses. Okay, so if you wanted to look up and do a little bit more work on this, this is year 10. Okay, this is the equation that you would have been taught. Known mass over known MR. So the mass that we know is that one there. So the mass of iron we know. We know the MR. Be careful, there's 2 of them. Okay, so it'll be times by 2. And then the unknown MR, the one we want to work out, is calculate the mass of copper. Okay, so you have to do times by 3. Okay, so be careful of that. Times it by 3, and that gives you a value by there. Okay, that's just that. So do look that up if you need a little bit of help, or come and see me. Balancing this out, so 2 chlorines, that means we need 2 chlorines here, 2 chlorines here. Cl loses electrons, oxidation is the loss of electrons. It's often found the increase in mass method using this method is greater than expected. Suggests the reason for this: impurities stick to the electrode. Suggests why this method cannot be used to measure the mass of chlorine. During this process, chlorine formed as a gas does not stick to the electrode. Blank page. These kind of questions seem to be coming up quite a lot. Okay, so you've got the demand and then how much is supplied. Okay, so you can see up till 16 carbons, the demand is greater than how much we can supply, and then it converts. Okay, this is why stuff like cracking is so important, because we can use these longer chain hydrocarbons to make shorter ones. This question's come up on both the triple and the double, so it seems to be quite a common question. State what is meant by cracking and give the conditions needed. So breaking down large hydrocarbons into smaller hydrocarbons, remember you end up with an alkane and an alkene. Heat and pressure. What you need to do here, okay, is all of the carbons on this side, can you see how I've times that by 2? You need to add up to the carbon by there. All of the hydrogens, can you see again I've times by 2, you need to add up to this. There's actually an easier question than you think. Give the meaning of isomers, same molecular formula but different structures, and then I've drawn 2 isomers. That's just the basic structure, and then that's an isomer with a methyl group coming off. Lots of information to read here. I'm not going to read it to you, you'll have it on your own exam paper. And then there'll be a couple of questions on the next page, just kind of looking at information. So use the information in the passage to compare the mass waste, volume of litter generated by the use of paper and plastic bags. Paper bags can produce a greater mass waste than plastic bags. Plastics cause more litter than plastic bags. Okay, sorry, than paper bags. That's all from the information. That's nothing that you need to know. Okay. Then tick looking at LCAs, whether the factors support the use of paper bags in preference to plastic bags. So the only one that does support the use of paper bags is this one. The rest of them support the use of plastic. Okay. Which type of bag is more likely to be linked to erosion of limestone buildings? Okay, that relates to last year and thinking about sulfur dioxide, okay, and acid rain. So that was relying on you thinking about last year. Give reason paper bags because atmospheric acidification. That should say something like the formation of SO2 and acid rain, okay, which erodes limestone. Nice graph there. This graph then, very strangely, was the 6 marker. Okay, you had to use the information in the graph. Did not need to use equations, which was quite nice. So temperature increases at acid until 25 centimetres cubed. pH decreases from 14 to 8. More alkali is neutralised. Max temp point indicates that alkali is neutralised pH 7. 25 centimetres cubed is the point to neutralisation. 25 to 50, acid is in excess. And then again, look in here. This comes up quite a lot, the ionic equation for that reaction. So that comes from the acid, that comes from the alkali or the base, and they make water, which is neutral. And again then, blank page, so if you do make sure you put the question numbers. Table of, loads of blank pages, table of ions and periodic table.